So if we have definitions for sides B and A, we could always use the Pythagorean theorem to figure out what side C of the triangle is. We could find the hypotenuse and then use any of the trigonometric functions. However, if I use the tangent of theta, then I can just go for the answer directly without having to figure out what side C is. So I'll use that approach. Of course, if I did the other way, so if I found C first and used the other trigonometric functions to find what theta was, that should also work just as well. So the tangent of theta is going to be equal to the opposite side, which is side B, and divide that by the adjacent side, which is side A. So in order to figure out what theta is, I need to use the inverse tangent of 2/3. Now the inverse tangent should be a button on your calculator. It may either say inverse tangent or it could say atan for arctangent, which is just another way of writing the inverse tangent. And if you plug that into your calculator, then the angle it should return is 33.7 degrees. So I would select that answer. If you did not get 33.7 degrees when you plugged in the inverse tangent of 2/3 into your calculator, it may be that your calculator is set to radian mode. And if that is the case, then you'll probably want to switch it instead of radian mode into degree mode. We will be using radians later on in the course when we're talking about rotational motion. But to start with, most of the angles we'll be dealing with will be in degrees, so you'll want your calculator in degree mode.